Hello guys, welcome to Crown's Maths. Just like we did in indices, we showed laws of indices. We're also going to do the same thing here. We're also going to show laws of logarithm. But before we do that, let us show the relationship between logarithm and indices. Now here we have that log n with respect to base a is equal to p. Okay, now this is for the logarithm part. Now we know that this is indices. A raised to the power of p will be n. So this is the relationship between logarithm and indices. So whenever you have log a certain number with respect to a base and it gives us p, now the relationship between this is just the base raised to the power of this will give us what? N. Okay, so that's the relationship between logarithm and indices. Now remember, logarithm means power, unlike indices. Indices still means power. Now this is read as, you can read this as the power of n with respect to what? The base a. Remember, the base is arbitrary, so you can pick any number to represent your base. So the power of n with respect to this base will give us what? The value p. Now I want to give out the laws. I want to show us the laws of logarithm. Now we have about 9 laws of logarithm. Okay, now here is the first one. The first one says log mn with respect to the base a. Now this mn, this is m multiplied by n. Okay, with respect to the base a will give us log m with respect to a plus log n with respect to what? The base a. Now the reason why I have plus is because I am multiplying this. Okay, same thing goes here. M divided by n with the same base will give us this minus this. Now the minus is because of the division. Okay, now observe that the base here remains the same. I did not change. There is no a and there is no b, so the base remains the same. So whenever you are given log m plus log n, always remember that the base will remain the same. Same thing applies here. Now here you also have log m raised to the power of n. This is log this number with respect to the base a. It's just the same thing as taking n to multiply log m with respect to the base a. Now this is also true for every logarithm. You can press your calculator. Logarithm of 1 with respect to any base, even if a is 100, log 1 with base 100, it will give us 0. No matter the base, log 1 will always give us what? 0. Now this one is also true. Log m, okay, logarithm of m, where your base is a raised to the power of b. This is actually your base, a raised to the power of b. This is equivalent to the same thing as saying 1 over b times log m with respect to the base a. This has a proof. Maybe in our next video I'll prove this. Also, this is one of the most interesting part of logarithm I love so much. This is log b with base a. It's the same thing as taking another logarithm of this 2. So this will be logarithm of b with, I introduce a new base e, and logarithm of this base here a with another new base e, the same base e, sorry. So always recall that when we have logarithm of, let's say, n with base e, this alone, this thing you are saying here is known as ln n. Okay, this is the same thing as this logarithm with base e. E is a natural number, is an Euler's number. So logarithm of this Euler's number is what? Ln, known as the natural logarithm. You know, there are two forms, there are two types of logarithm: common logarithm and the natural logarithm. Now common logarithm is the one with base 10. Whenever we have logarithm with base 10, so this is your common logarithm. common logarithm, then this is your natural logarithm, either this or this. Now another one is when you have logarithm of the b, logarithm of b, or the number b with respect to the base a, is the same thing as saying 1 over, then you just switch this, so the base here becomes the number and the number here becomes the base. Okay, and this is true for all logarithm where you have logarithm of the number and that number too is also the base. The answer is always equal to 1. This also has a proof. Now this one too is also true. You have a raised to the power of, this is a raised to the power of logarithm of x with respect to that same value a. I did not put b here, so a raised to the power of logarithm of x raised to the same logarithm of x with the base a will still give me x. Okay, now I think that's all for the laws of logarithm, which is true. Okay, now if I want to prove this one, now this using my relationship, I will say log a with base a is equal to 1. Now what's the relationship between logarithm and indices? And this is a raised to the power of 1 is equal to what? A. Okay, let me not use put this as 1, let me put this as n. Let's say log a because we don't know if it's giving us 1, let's just use it as n, so this becomes n. So this is actually, if you watch, this is a raised to the power of n and this is a raised to the power of 1. What does this imply? This implies that n is equal to what? 1, because these two are equal. Now this is a raised to the power of n equal to a raised to the power of 1. What does this imply? That n is equal to what? 1. Therefore your n here is what? 1. So we have proven this one. Thank you. In our next video we are going to show how to prove this one, and please don't forget to subscribe, very important. Thank you very much.